This video is going to teach you how to graph trig functions or the sine and cosine functions. So this is a unicircle, and if you don't know what that is, I would suggest watching a video about it or just learning about it. And on the unicircle, the y values are the sine, so sine equals y, just write that down. And the cosine values are the x values for each point on the unicircle. We'll get to cosine later, but we're just focusing on sine right now. So on this point where the angle is 0 radians, the y value is 0, which means that for the graph of f of x equals sine x, if the x is 0 or the degree or radian is 0, then the output will also be 0. So that means the y-intercept or x-intercept is at 0, 0. And if we're at this point where the angle is pi over 2 radians, then the y value is 1, which means that if you plug in pi over 2 into this function, you get 1. So let's draw that. Pi over 2, 1. These are 2 points. And you can keep testing values. For example, pi, this is 0, it's a point here. And 3 pi over 2, this is negative 1. 3 pi over 2, negative 1. You can keep testing values, but this is what the graph is going to look like. It's like this. Draw the points like this. It's not the greatest, but it's going to look something like this. I'm going to redraw the graph so it's a bit easier to understand. These are y-axis, these are x-axis, and we already figured out there's a point at 0, 0. There's a point at pi over 2, comma 1. There's a point at pi, comma 0. And there's a point at 3 pi over 2, comma negative 1. But what about the negative values? Let's try negative pi over 2. What is sine of negative pi over 2? Well, that's just the same as sine of 3 pi over 2, which is negative 1. So there's going to be a point here, which is negative pi over 2, comma, negative 1. And you can see this graph repeats. Let me just draw the line right now. And this graph actually repeats. So, like I said earlier, for each angle that you plug into the sine function, there's another angle that could produce the same output. So, here, this is what repeats. This line right here. This is called the period. And here, it is 2 pi long. So usually the period is 2 pi for a regular sine function. But if you do transformations on the function, the period can become larger or smaller. And the height of this is called the amplitude. Right now the amplitude is 1 because we haven't done it in transformations. But usually, to calculate the amplitude, you need to figure out how much this is dilated by. What I mean by that is since this is this function is too tall right now because it goes from negative 1 to 1, so it is too tall. But if this were negative 2, 2, negative 2, if we did transformations to make it look like this, then the amplitude would be 2 because it goes from too tall to 4 tall. Okay, let's recap. So This is the shape of the sine function. This is f of x equals sine of x. And the period is one segment where the graph can repeat from. So if you take this, you can like copy it over here. It's the same thing. And the period is the length of that segment. In a regular sine function, the period is 2 pi. And the amplitude is what I like to say the height of the graph. Usually the graph goes from -1 to 1. So the height would be 2. But if the height were to be 4, for example, if this was -2 to 2, this is the height of 4, the amplitude would be 2 because they're multiplying the height by 2. But usually the amplitude is just 1. Now why does this matter? If we have a function where we're doing transformations to a sine graph, for example, like this, f of x equals 3 sine of 1 over 2x. What is the period and what is the amplitude? The amplitude would be 3. The amplitude is always the number in the front of the equation. If there is none, then it's just 1. The period is this. The period is a little bit more complicated. To find out the period, you do 2 pi over b, and b is this number, the number which is right in front of x. If there's no number right in front of x, then the period is just 2 pi. But in this case, it's 1/2, so period will be 2 pi over 1/2, which is equal to 4 pi. Period would be 4 pi. And now I'm going to describe the other transformations, which are all pretty simple. So let's say if the equation was 4 sine of 1/2 times x minus pi over 2 plus 4. You can see the new numbers we have are this and this. And if you've had any experience with graphing like quadratics or really any other function, you could probably guess what these do. This 4 moves the graph up 4 units. So this -2 would go up here to become 2. This 2 would become 6. In the middle of the graph, which is 0, would become 4. And this negative pi over 2, the negative sign means the graph moves to the right. If it's positive, it moves to the left. And the pi over 2 means if it's negative, it moves to the right by pi over 2. So this point would go here. If this point was like pi over 2, it would move to the right by pi over 2. If it was positive, if it was plus pi over 2, then it would move to the left, meaning it would move this direction. Now let's talk about the cosine function. The cosine function is actually pretty much the same as the sine function when graphing. It's just moved a little bit to the left. So we have f of x equals cosine of x. It is the exact same as sine of x plus pi over 2. And if you think of the reasoning behind this is that on the unit circle, since this point is 1, 0, and sine is a y value, sine starts at 0 and cosine starts at 1. But since it's a circle, both the y and x's have the same pattern, which means that they both move in that same like curvy pattern, but they just start at a different value. Now let's draw the graph of the cosine function. I drew the graph of the sine function here, and this point is 0 over here. This point is pi over 2 over here, like we've mentioned earlier. This is at 1. And since the cosine function is a sine function but shifted left by pi over 2, this point right here, the axis intercept, is going to move over to here because this is where negative pi over 2 is. And this pi over 2 comma 1 is going to shift over to the y-intercept, which means on the cosine function, the y-intercept is 0 comma 1. So let's draw that, just really roughly. can draw this point being shifted over here and everything else being shifted over. It's going to look like this, where this 0, 1, negative pi over 2, 0, pi over 2, 0, and so on. So this is a cosine function. That was a lot of information that I just explained, and I don't expect you to know all of it. But if you think you do, then you can try this practice problem. So just pause the video and try it for yourself. But I'm going to explain it right now. So, when drawing the graph, the first value that we have to look at is this number right here. The number right in front of the x, which is a 2. If it says like sine 3x plus 3, without these parentheses around the x minus whatever or x plus whatever, then you have to factor it out to make it sine 3 x plus 1, like this. Okay, so that's just a note if you ever see that. But and we already explained earlier that we can use this 2 to find the period. So it's 2 pi over 2, so the period is pi. So first, let's just draw the regular sine function graph. Like this. Doesn't have to be pretty. I'll just draw it. Like this. And since the period is now pi, where the period usually is 2 pi, this is going to be squished into here, this is going to be squished into here. So everything is going to be squished to like half. I don't know how to explain it well, but I'll just draw it like this. So this is a period now, when before it had to be like this over 2 pi, but now it's squished into half, as you can see. You can just repeat that over and over. Like this. This is the new graph. And of course, don't forget to label 1 and -1. Our second step is to look at the value to the right of x. If you have a function where this value isn't there, then just skip this step. This means that the function is moved to the right by pi. And on this one, this is a special case because the function actually stays the same. Because if you just think about it, this gets moved to here. Oh, the point's already there. This gets moved to here. Point's already there. This gets moved to here. Every point that should go somewhere is already there. So it stays the same. But the next value we should look at is this 2. The next value you should look at is always the value before the sine function. So this 2 means that the amplitude is 2, as we already said, which means that these values are going to be multiplied by 2. 2 and 2. -2 and 2. The y values are going to be multiplied by 2. And that's a pretty simple step. And the last step is this number. This number, as we said earlier, is moving the graph up or down. In this case, it's moving the graph up by 1. Which means that it's no longer going to be -2 and 2, but instead the lines where it matches up with is going to be -1 and 3. And it also does not match up, it doesn't have symmetry, I guess, with the x-axis. Instead, it has it at y = 1, because that's the midpoint between 3 and -1. Okay, I'm going to redraw the graph because it's kind of cluttered right now. So let's just move down here. Let's draw axes. And now, let's draw the points where it lines up with 3, 1, and -1. And now I'm going to plot the new points. So looking at the red graph and shifting everything up by 1. So this right here is going to be moved to here. This here, I already changed this to a 3, but originally this was a 2. So here, it's getting moved up here. It's getting moved to -1. And here is where pi is. Pi gets moved up to the y equals 1, and so on. And this is 2 pi. Let's just put another value right here, just so it crosses the axis. So this is what final graph looks like. Obviously it's going to be more neat. I just can't draw on a mouse, but this is what the final graph looks like. Here is pi, here's 2 pi. Some points are pi over 2, so this would be pi over 2 comma 1. This would be pi over 4 comma 3. This would be negative pi over 4 comma -1. Those are just some points. You can calculate the rest. But the most important thing to remember when graphing is that the sine and cosine functions repeat, which means that if you take the period, we talked about the period. If you take the period, you can just repeat and repeat the period by just copying it and drawing it again to the left and to the right of the graph. I'll draw a visualization here. So let's say this is a period. You can just copy this by drawing it again like this, drawing it again like this, drawing again like this, draw like that, and you get a cosine or sine function by drawing that. That's the most important thing to remember, is that it repeats. Okay, hopefully you were able to follow along in the last question. I have a new practice problem using the cosine function instead of sine function. If you think you can do it, then pause the video and try it for yourself. But I'll explain it right now. So, as I said in the last problem, this number is always the first one we should look at. And we have this number, so we should do it. And you can use this to find the period by doing 2 pi over 1 over 2. I've done this many times. I've said it many times in video. Should be easy now. And let's draw the original cosine function right here. Like this. Doesn't have to be good. I'm just drawing it to show you. And original cosine function has points here where the graph lines up horizontally. And the part where it can repeat, which is the period, is 2 pi. This segment right here is usually 2 pi, but this equation makes it 4 pi, which means that here, instead of being 2 pi, it is 4 pi. And right here is 2 pi instead. And here is 3 pi, here's pi, and here's negative pi, so on. And now, the next number we should look at is a number close to the right of x. It would be right here, but we don't have one. So we skip to the beginning of the equation to the number right before the function. There should be a number right here. It's just 2 or 3, but since there's none, we skip that step. And then we look at the number at the very end of the equation, the one after the function. Here it's plus 3, which means that we're moving the graph up by 3. So let me redraw that. I'm going to move down a bit. So let's redraw this graph by moving it up 3. So this -1, where it lines up horizontally with the bottom of the graph, is going to be moved up to 2. Because it moved up 3. This one going to be moved up to 4. And it's not going to line up, it's not going to have symmetry with the x-axis anymore. Instead, it's going to be moved up 3 to y equals 3. And let's just move all these points up by 3 values. It shouldn't be that hard. Just do like this. this. Okay, this is your final graph. Obviously, this should be touching this point, so. And these are the x values. And that is your final graph of cosine of 1/2 x plus 3. We have dilated the graph by 2, we stretch it out, and we moved it up 3. Those are only transformations, and this is the final graph. And yeah, those two practice problems that I just went through should give you everything that you need to know to start graphing sine and cosine functions. I would recommend doing more practice problems just to solidify your understanding. But if you are still confused or you don't know something, then please ask it in the comments and I will reply to you, guaranteed, to help you. And if you learned something from this video, please consider liking or subscribing to not miss future content and to learn more math. Thank you for watching.